Hi there, this is Dr. Bart. I am the professor for CISC108. Some of you were not able to make it to class yesterday, either because you joined late, welcome in that case, or because of the snow, or any other factor. I wanted to make sure that you got to receive the same lecture as all the other students. Now, normally I use UD Capture, and you'd just be watching the recording of me having lectured. Unfortunately, for some reason, the video didn't capture yesterday, so there's nothing up there on Canvas. You'd be able to find it under the My Media section of the Canvas website. That's why I'm making this video. I'm going to do it in one take, so it might be a little choppy around the edges, but hopefully it should cover all the things you need to hear. Pretty much everything I say can be found in the syllabus. I've tried to make sure that I have a formal written record of everything about the course policies and stuff. But some people prefer to hear it, so we're going to get started. As I said before, this is for CISC108, Intro to Computer Science. Normally, we'd start off by doing a little activity where you introduce yourself. We're not going to be doing that remotely, obviously. Instead, we'll get started talking about who I am. As I said before, my name is Dr. Bart. I am an assistant professor in computer science here at University of Delaware. I did my doctorate at Virginia Tech in computer science. I also actually did my undergraduate degree here at Delaware about 10 years ago or so. I graduated class of 2012 in computer science. I do research in computer science education. That's my primary area. I also do program analysis, data science. I do some web development, not really research, but actual development. And I dabble in a few other areas. Over there on the left, you can see a picture of me with my corgi puppy. I am the one on top, and my corgi puppy is the one in my hands there, in case you can't tell the difference. Let's see. Her name is Ada, by the way. Now, there's a number of other members of the course staff, the TAs in particular, Marissa, Tyler, Percy, Stephen, Julia, and Rachel. I've worked with most of them last semester, and they're all fantastic. I'm going to tell you more about the course staff on Wednesday, and you'll get to meet them yourself on Thursday during your lab session. For now, you should get starting to know their names, because they're going to be important. I asked the class some history about themselves, some information about themselves. Not these actual questions, a different set of questions, but the gist of it is that a lot of students are freshmen, and there's not actually that many computer science majors. There's a fair number, but not the majority of the class. And a lot of people don't have prior programming experience. So odds are, if you're watching this video, I just described you, and you should feel comfortable. But, you know, welcome to you if you're not. We'll take all kinds in this class. We also started off with a fun little activity. I thought it was fun. Who knows what everyone else thought. We had this table of data, and the story was that your friend has heard that you are taking CISC108 and very excited, and they want you to help them with a data problem. They work over at Trabant, and they have millions of records like the table over here on the right. And they want to know the name of the coworker who has sold the most chicken sandwiches last year. And I asked you to sit down and write an algorithm that can find the answer to that question. And there was a little nuance in there, like we wanted only the past year. Some of the employees put down negative numbers, and that data has to be ignored. We only wanted chicken sandwiches, and we wanted the name of the employee who had the most. So students had about 10 minutes. If you would like to engage with this, you can stop the video right here and try writing down an algorithm and seeing what you come up with. I'm not going to wait 10 minutes real time for that. You can pause the video. Now, assuming you did, then you would probably be able to look at the instructions, and they're probably at a fairly high level. I assume you wouldn't write any code for this. I'm pretty sure I could take any one of the instructions and break it down further and ask you to say, commonly, most of the students would say things like, well, go look for all the chicken sandwiches. And I'd say, well, how do we find all the chicken sandwiches? And we could say, oh, well, take your finger and trace down the table, go through each row. And if the first column of the first row says chicken sandwich, then we'll keep this row. But if it doesn't, then we'll get rid of it. And then we can go down, second row, do the same thing, and the third row. And we can take any one of those instructions and break it down again and again. And this starts to get to the idea of taking algorithms and decomposing them and building them back up and figuring out how to express them with precision. And that's a lot of what we're going to be doing. I mean, the kind of problem that we see here is actually one that we'll probably end up being able to solve by the end of the semester. But we'll use actual programming language instead of just, stuff in the air. When we came back from that, I thought this was a good opportunity to sort of introduce the idea of computer science. This is an intro to computer science course. It's going to be featuring Python. If you're familiar with programming languages, we're using the popular programming language Python, which we'll talk a lot more about on Wednesday. And this is different from how the course has been taught in the past. A lot of the things about this course will be different from how they've been taught in the past. We're trying a lot of new stuff. Could have some rough edges, but I think it'll be a very exciting opportunity for you all to learn a lot of really cool modern stuff. Now, the programming language is important. It's a thing that has to be discussed, but it's not really the biggest question, I think, on everyone's mind. A lot of what we need to be thinking about is, what is computer science? And there's a misconception here, I think, for most students about what computer science is, because it's not really about computers. We're not going to talk about hardware. It's not really about programming. So even if you thought it was programming, it's not quite correct. And it's not really even a science when you get down to it. Instead, most people describe computer science as the art of problem solving, usually using a computer, usually using programs, software, but not necessarily. Now, granted though, programming comes up in a big way. I mean, you can't ignore it. It's the most useful way of solving a lot of problems in computer science. So of course, we'll be doing lots of programming, and that'll be a big component of the course. But it's also not accurate to try and, box computer science into nice, simple, clean categories, because in its heart, it's a science and a craft and an engineering form and an art form and all these other different ideas. I think in a certain number of years, we're going to see that computer science has its definition expanded to include a lot more than what we traditionally thought. And it won't be siloed in a department, it'll be given across an entire college. Because you'll see majors like computational law, computational history, computational biology. Oh wait, that one already has existed forever. I mean, things are changing and only getting more and more pervasive in computing. So that's sort of an idea of what computer science is. You're probably also wondering, some of you, why are you here? Why are you taking computer science? As I said before, the field is dramatically expanding. But the reality is that we can't keep up with the demand for computer scientists. We just don't have anywhere near enough people with the skill set that employers want. It's a hugely growing area. So these kind of careers, you get a degree in computer science, you'll have a job, and you'll find that you can make a tremendous amount of money. So there's the guaranteed employment component. It's also empowering. I mean, the ability to write programs and create software and solve problems allows you to change the world, allows you to do new things. I mean, think about what the world was like 20, 30 years ago. Not everyone had a phone in their pocket that could access a massive, infinitely expanding database of knowledge. And you couldn't have self-driving cars and other modern miracles. And if that isn't persuasive, hopefully you can share my sentiment that computer science is fun, that programming is fun. Not everything we do is going to be interesting and enjoyable, but I think a lot of it actually ends up being a good time. So hopefully you can be convinced by that. Now we've talked about what computer science is and why you should take it. Now let's talk about how. Some of you are new to programming. Some of you have been programming for years. It doesn't really matter if you have experience or not. My advice is going to be the same. You need practice. You need immersion. You need to treat this like you were learning a new language. Because you are. I mean, programming, learning to program activates the same neural circuitry as learning a second language. It's language-based and not math-based. Yeah, sure, you need a little bit of math in this course, but not a whole lot compared to, say, a lot of other STEM disciplines. Instead, think about regular amounts of spaced practice. You're learning a new vocabulary, you're learning a new grammar, you're learning a new way of thinking. And alongside all of that practice, think about your schedule. Think about how you do all this and what time you spend on this. Because let me tell you right now, the biggest way to succeed in computer science is to start assignments early, work often, and work in short bursts. Space it out. Don't wait to the last minute to start stuff. I've seen so many students who fail because they don't take this advice under consideration. And I've seen a lot of research now that indicates that if you start assignments early, you will do about 1 letter grade better, regardless of whatever talents you have. There's a lot of ways to succeed if you follow these instructions, but it's easier to say than done. I mean, it's easier said than done. Other suggestions, take advantage of the course resources. Your partner, as we will talk about, will be a great help, as will myself and the rest of the course staff, the TAs, will have regular office hours. There'll be the textbooks that we'll be have access to, instructional videos, lots of assignments. There's a lot of ways you get to learn in this course. So we'll talk more about those in just a minute. But I want to just say one more time, make sure you're figuring out that you're doing lots of practice in this course. I said before there is a textbook, but I don't want to make you scared. They're all free and online. How to Think Like a Computer Scientist is linked on, all three of these are linked on Canvas. Coding for Beginners and Easy Steps is actually not free. It is a physical book. You can get it or not. I don't care. It's up to you. If you want it, you can go get it. It's okay. It's a little out of date. Anytime you print a textbook in computer science is out of date. The other two books are more up to date, and they're both free. You can read them online. How to Think Like a Computer Scientist, that has a, what's it called? They have interactive exercises. Let me point this way. They have interactive exercises that you can complete while you read it. So that's pretty cool. So looking at the format of this course, just to get you a sense of what we're going to be doing on the regular, we have a module system. So every week is a new module. Module is composed of 2 to 8 lessons. And each lesson, in turn, is composed of videos, which are, some either a YouTube video with some slides and transcript, Canvas quiz, and then some programming problems. Not all of them have programming problems, but most of them have programming problems. And you'll have a certain number of those. And then you might also have supplementary projects, surveys, readings, reflections, critiques of code, and a few other different things and the activities we do in class. And those will vary from week to week a little bit, but all of it's going to be stored in the module view of Canvas. So when you go to the module view in Canvas, you can access to all the lessons and all the other supplementary activities for that week. We have several assessments in the course. So I mentioned that there's the projects. The projects are throughout the semester. They get increasingly bigger and more interesting as we go along, culminating in a big final project, and that will be multiple weeks long. It's an opportunity to express some creativity, but also a form of assessment. We want to know how you're doing. Parallel to that, we also have the exams. There are 2 midterms and a final exam. They are individual, and they will assess how much you know. I have a policy in my course that you cannot get higher than 1 letter grade higher than your average exam grade. So you got to do well on the exams. And as you'll see, you have a lot of ways to get support on programming assignments and quizzes, but the exams are where we see if you actually have learned anything. Another whole element is that exams are going to be done at the testing center. So that's slightly to the eastern side of campus. You'll need to coordinate how you get there and schedule in advance. We'll talk more about that around week 4 when we're getting closer to it, because the midterm will be week 5, the first midterm. Talk a lot more about that later. Due dates are an important concept in this course. So every assignment has a due date. I don't allow late submissions. There are no late penalties because I don't allow you to submit past the late date. When an assignment's due, it's due. That's just fair for the students. A module will open all at once. All of its assignments open at the same time. And I promise I will always have the module open the Friday before class. Assignments won't appear just during the middle of it. And then they will lock the Friday of that module. So module 5, for instance, opens on a Friday. The following week, Monday, Tuesday, Wednesday, Thursday, Friday, then it will close at 11:59 p.m. on that Friday. I'm going to do my absolute best to have modules open way in advance, though. My goal is to try and have them open as soon as they're ready. Also, the first module is lasting 2 weeks, so you get a bit of extra leeway there because people are adding and dropping and stuff. And we'll see if module 2 also gets extended a week, but currently assume that it's going to close that Friday. So you want to get started on the assignments and finish them in a timely fashion. Occasionally assignments will have a due date that is earlier or later, almost always only later. I don't think there's going to be any earliers, but you should pay attention to due dates for each individual assignment. The projects is what I'm really talking about here. Some of them will be due, after 2 weeks or 3 weeks to make sure you get a chance to really do a good job with it. But really, just pay attention to due dates for assignments. I don't like talking. I am a very talkative person, but it doesn't help you learn. So I try to avoid talking too much during class. Ideally, no more than the first 20 minutes will be spent on lecture and trying to get you introduced to an idea or doing something. Um, then maybe the next 10 to 20 minutes will be group work, clickers, and worksheets, ideally even earlier than 20 minutes in. But this is where you'd get to reinforce some concepts and work on some stuff. And then the last half of class, in my ideal vision, will be actually working on programming problems and quizzes and getting help from me. So I'll be walking around, providing support. It's essentially the lab time in class, in addition to you having the actual lab. Attendance during lecture is not taken, but we'll often have graded activities during class, including clicker activities. So if you miss it, you don't get the points for it. So it's kind of attendance in its own way. But we do take attendance in lab, and you are expected to show up to lab. There'll almost always be assignments that you'll be able to do, so there's no reason to be able to miss lab. And occasionally we'll have assignments that can only be done in lab, which the TAs will talk about during their opportunities. I mentioned the clicker. Two pieces of technology you need in this course. You need a laptop. You need to bring a laptop to my class. This is a computer science class. You need a device to program on during class. You have to be able to install software on it. I expect you to install Thonny. That's lesson number 2. We'll be doing that in class on Wednesday, making sure everyone can get it installed and everything. And we'll use it for other activities too, maybe mock exams and stuff. You'll be using this laptop regularly, writing code on it. Make sure you back up all of your code, all of your assignments. Back it up using Google Drive or something. Email it to yourself if you have to. It's not a valid excuse to lose your code the day it's due because you didn't have backups. I'm very serious about that. The other device is a clicker. You need to get a hold of one. They're not too expensive. Get it used. Borrow from a friend in a different class. Make sure you register on Canvas. Starting on Monday, next Monday, we're going to be using them. So you need to make sure that you have it pretty soon. And we'll ask various questions. It's mostly participation type stuff. But you know, we'll talk about those questions. They'll be important ones that reflect true understanding. The Canvas site, this is normally where I'd have a demo of the Canvas site. I'm afraid you'll have to go without. If you have questions, I recommend you come to office hours for myself or one of the many TAs. They can get you sort of oriented around the Canvas site and help you understand how to use it. The most important thing is the module view, but if you click around, I think you'll be able to understand most of it. Don't be afraid to post on the Piazza, as we'll talk about in a minute, to get more help. There's also an autograder used in this course. Very important to mention is the autograder is off the Canvas website. You will need to use, if you're on campus, you'll never know that there's any issues. You have to log in and stuff and enroll in the course, but there are instructions for that. But if you are off campus, if you're traveling for some reason, for instance, you will need to use a VPN. So this is very important. We have instructions for how to install it from the university. We won't help you get it installed though. The university's IT will help you install it. If you have any issues or anything, we send you to them. You can post in the Piazza to get more help, and we might be able to help you, but don't expect that. It's just because it's not, you know, local software. It's just this is like a real tool that people actually use and stuff. I've never had any trouble with it. I use it all the time. I have to often log in from off campus. But we'll talk more about the autograder on Wednesday and Friday. As you'll see, there's a lot of the starting activities get you oriented on how to use them and stuff. Now, there's a lot of good opportunities for help in this course. I've already mentioned the Piazza. So this is an online forum built into Canvas that you can access through Canvas. You can post questions, and your classmates and the course staff can help. We'll try and answer the best of our ability in a timely fashion. Last semester, we were averaging 15 minutes. I don't know if we'll meet that every semester, but we were doing pretty good. The TAs were really helpful. This semester, every semester, you got to make sure that you don't post answers that are inappropriate. We'll talk more about cheating and collaboration in a little bit. But that's a major source to get answers to questions. Don't email me about most things unless it's really individual, like, you know, a medical excuse or something. The goal is to put it on the Piazza. I also have office hours, and the TAs all have office hours. The TAs' office hours are fantastic. They are very smart. My office hours are pretty good too. Personally, I get lonely during my office hours. Please do come to my office hours. I love having new friends. We can talk about computer science. We can talk about the course. I'm just going to be sitting there doing nothing, so you'll be doing me a favor. Come help me. Come talk to me. There's a textbook. We already talked about those. You have your classmates. We have your partner. We'll talk more about that in a minute. And of course, Google, but I want you to be careful about using Google. You can't just take code you find off the internet and just massage it into working. That's not going to help you learn anything. And remember, when you get to the exam, you won't be prepared. So, keep that in mind, is be very cautious how much code you take off the internet, and also be sure to be, attribute it correctly. If you say you got something off the internet, we're going to look at it very closely. And if we find out you stole some code without saying you got off the internet, we'll be very upset. Don't hand in some project you found online as an answer. You will get in serious, serious trouble. Now, in the real world, programming is not a solo activity. This is a very common industry as you work with others very closely. Sometimes you even work with them in a style called paired programming, where one person has the keyboard typing and the other person is the navigator, giving suggestions and instructions on what to do next. You don't have to follow the paired programming model in our course, but you will be assigned a partner during the first lab. Until then, you can just work on assignments on your own. The idea is that collaboration with your partner is mandatory on the programming problem sets and the mastery quizzes. So you work together. Everyone's handing in their own copy, but you can talk to each other and help each other figure things out. Now, this doesn't mean you cooperate by splitting up the work and just you take half and I take half sort of thing. That isn't good. You won't learn anything from that. You'll be wildly unprepared for the exam. Instead, the goal is for you to sit down and actually work together to get through all the problems. And you'll learn a lot more and have a better time if you do that. The other assignments, besides the programming problem sets and the mastery quizzes, you can assume are individual unless you're explicitly told otherwise. And the syllabus goes into a lot of depth about how all of this works. If you have any questions, I'll either point you there or you can ask me and we can clarify. Now, you have the partners, but there are ways to cheat in this course. So let's talk about that. Don't take code from anyone besides the course staff. Your partner shouldn't send you the answers to questions. You should be sitting down and working on them together. They might give you some high-level advice and stuff, but they shouldn't just be sending you answers to problems. And certainly, you cannot take code from someone besides your partner. And you better not be sharing code on assignments that aren't paired. So, for instance, most projects are individual, and sharing code is an academic violation. Let me tell you right now, I've had to do this before now. I've done this here at Delaware. It's easier than it was at my former institution. I am not afraid to write people up, and it's a pain in the butt. Even just being charged is like $100 to be processed through their system. Basically, don't cheat. It's really not worth it. It's really obvious on our end. All the stuff that you submit through our systems gets checked against everyone else's answer. We know if it's identical, and there's lots of little obvious tells. There's a lot of research on this stuff. So, but it's a pretty simple model. Don't cheat. Work with your partner and work in high-level ways, side by side, and there won't be any opportunity for you to have any issues. Make it clear who you worked with. Make sure the TAs know who your partner is. There'll be a thing for this. Otherwise, be respectful to each other. Make sure that you're communicating using professional language and being nice to each other. We're all in this together. I mean, I don't want this atmosphere of worrying about cheating. I want us to be collaborating and learning from each other. I had some concerns last semester from students early on about the pacing of the course. Now, this is a different course. We've revised pretty much everything from the ground up. But I know a lot of you haven't programmed before. And there's a lot of content in this course. I mean, learning a CS, any CS1 course, no matter where you go, it's a lot of content to cover. And unlike in math and English, you haven't been doing this as a child. I mean, this is all brand new for some of you. Learning a program is like learning a language, right? So you need to take time to do so. I expect about 6 hours outside of lecture and lab each week. That's the standard. That's, twice the number of credit hours is the actual federal law about this. And that's what I'm going to expect of you. I'm going to try and design the course so that you aren't spending more than that on average. Some of you might need more time. Some of you might need less time. There's a huge distribution here. It's a big normal distribution of talent levels and everything. Experience levels, not talent. And some of you will do better or worse. For those who are struggling early, you should come to office hours. You should get the help you need. For those who are doing really well, who are acing on the material, maybe you've seen a lot of this stuff before, you're just browsing through it, here's what you do. We have these code beyond activities. They're worth stars. They're not worth points. They are worth 0% of your final course grade, but they will have an indirect effect on your final course grade. The more of them you get, the bigger the effect. Now, I say that, but it's also a decaying logarithm. So 4 is, 8 is, you need 8 in order to be, let me slow down for myself. If you get 1 or 2, then you'll get a certain small impact on your final grade. If you want to get a bigger impact, you don't need 3 or 4, you need more like 7 or 8. And then the next tier up after that is like 15 or 16, then 31, 32. And as you get more and more, they're kind of worth less individually. And you need lots and lots in order to make a big impact on your final grade. The assignments, these code beyonds, they're challenging. They're meant to push you more further into computer science. They should be very interesting, though. I think each one is meant to be this sort of unique little learning experience. You can only attempt the code beyonds if you finish all the other assignments for a module. They're not, they're not for students who are struggling. They're for students, they're enrichment opportunities for students who want to be pushed further than the course usually allows. It's up to you to sort of figure out where your healthiness, where you find a healthy balance. You might complete all the assignments and find you don't want to engage any further. You got to go do your physics class homework or stuff. Perfectly fine. These are opportunities for you to go further if you want to take advantage of them. Totally optional. But if you're not doing well, if you're struggling, that's perfectly fine. We all struggle learning something new. The important thing is that you reach out and you get the help that you need early. Don't bash your head on any given problem for more than 20 minutes before you try and get help from a human. At this point, I opened it up for questions and allowed you to ask whatever you wanted to ask. Obviously, I can't do that, but the Piazza is open, so please do post questions about logistics, and I will be more than happy to answer them. Normally, I would then open this up for lab time. You would be expected to stick around, work on class assignments. I would come around and help you out. We're obviously not doing that here, but I'll point out now, you've got Module 1 and Module 2 open, and you can get started on it. Both of those, all the assignments from those are due next Friday, not this Friday, but the following Friday. So get started on them, start making progress, and don't be afraid to ask questions. Now, this is, I think, covered all the ground that we had in class. I managed to go a little bit faster than in class. I just want to also say I'm very excited for this semester. We're trying a bunch of new things. I always love teaching introductory computer science. I think we're going to have a great time, and I'm very excited to be your professor. So, goodbye and good luck.